Hello, hello, hello. Okay. Let me check if I have any changes. Right, a few. Okay. Wait. Oh. We're going to start soon. Very soon. Okay. Should be... Well, actually, just one more. Yeah. Okay. Let's fix the volume. I love this music, but yeah, it was a bit loud. So now that we're here, bar hidden, and yeah, should be good. Hello peeps. So, let's start the game, shall we? For now we have this. And the difference is, last time what we did is we managed to construct some kind of dungeon, you could say, that looks like this. It actually looks kind of bad. For now. I mean, the blocks should be different, right? The texture should be a bit different, but yeah, it's like kind of empty inside, right? In the first place. What else? Like this, there's this kind of tower, but yeah, I think I just suck at designing castles and that kind of stuff. But yeah, we have this, and you can see that if we look around, it's like looping over all the donut, which is pretty nice, you could say. And we can set the position. Actually, we can't set it arbitrarily. There's some kind of bug, I suppose. But well, good enough. I don't want to think about that today. Today I actually want to take care... Oh, it's still a bit loud. I actually want to take care of something that's really important for our game. That is going to be the cornerstone of the game, which is saving. I want to save chunks. And this is pretty simple, right? In theory. But we just have to do it in practice. And we actually have some kind of voxel database, right? If you remember. That basically stores like our voxels, right? The information for our voxels. And this is going to matter because the database might be different, right? The indices to the blocks might be different depending on when you play the game, right? Yeah, okay. Just a bit more. Okay. So, the thing is, do we want to make a class? Yes, we want to make a class for that. Probably in voxel core. Because it's going to take care of saving chunks, right? So we have the core. And maybe just there. Directly. I want to see if I push things here too. I think I did, but CMD, let's see that. Oh, I didn't. Oh no. I have to push some things. So that was about the generation, right? Okay, that's not what I want. 46, so it's going to be 47. Voxel 47, and this is Dungeon Biome. Dungeon Generation added, I guess. And we have the same here. So we're gonna have the biomes. Important. We are going to have this with battle action, I guess. Yeah. And register types. Okay, do we have anything else? I don't think we do. So we're gonna push this. Send message. Actually, just a bit different. It's going to be dungeon generation added. Biomes are now resources. Okay, should be good. So, now that we have this, we are going to create new files. Voxel core, and we are going to have something like conversions. Let's go with chunk. Let's go there, and it's going to be. Actually, I already have a chunk loader, right? Do I want it to save? Do I want a serializer, maybe? Maybe I want a serializer. Chunk serializer. So I can potentially... You know, so the goal is that I can send the chunk... Well, I can save the chunk on the file, but I can also send the chunk over the network efficiently. So we need a serializer, not just a loading. So chunk serializer. Is the chunk the only thing that's going to be serialized? I don't know, and I don't care. I'm going to open this. Good do. Okay. We have this. We are gonna have... Gonna have this. And it's gonna be good. Maybe. Maybe. Just gotta wait a little. I don't know if it's helping if I just close... Well, I mean, I'm gonna close the game anyway. Yeah. And... Do I want to close the engine? I mean, I guess... We're gonna do that. Then we have... Core. Let's start modifying the serializer right now. So, chunk serializer. Same there. Wow. Pragma once. I want this to be... I actually don't know. An object, a node, a resource. I actually have no idea. Maybe it should be a singleton actually. I guess I should be able to access it from... Yeah, a singleton is not a bad idea. Because it's a tool. For now, let's just remove everything. Okay. Maybe it's gonna be an object, maybe not. Go to instantiate object. Can you do that? Preload the scene. The scene. Pure class or null. Just point new. It's a node. Okay, so I actually have no idea what this should be. If it should be a node or not or whatever. So I'm just gonna keep it like this for now. And let's say it's a node for now. I think that's a bit bad, but okay. And we're gonna have a serialize function. And we're gonna have a deserialize function, maybe. And inside we're gonna have something like serialize cube chunk. So something like cube chunk. I guess just cube chunk is fine. And maybe we're gonna have multiple serializer classes, but that's fine. So we have this. Deserialize. Well, first, I guess this is gonna return bytes. We could return a string, but technically it's like an array of bytes. So like local vector of bytes. The reason we do this, out bytes, the reason we output here and not here is because if we return the local vector, that means we need to allocate memory. But if we take it as an input, that means we can potentially keep it in cache outside of this function. That's the reason. And serialize, okay, into bytes. And deserialize from bytes to this, right? Okay. Let's reload. Here we go. Technically, I could maybe just return, but maybe it's like a deserialize into, right? I'm not sure. I'm not sure how it's going to look like, really. Here we go. And the serialization is going to be quite simple. Well, not really. Well, I guess it's a bit complicated. Modules? Wait, I can't include modules. Wait, what? Wait, what is this? Wait. If I go there, for example. Modules, no. Cube chunk space. I can't do that. Chunks, cube chunk. Something like this, and it should be good. Maybe. I'm gonna try to start to see if it compiles. And local vector is not detected, so I mean, it probably should be with cube chunk. But okay. And serialization, we're gonna have... Oh, right, I wanted to have... To split... Well, I wanted to have different kind of memory layouts for a single chunk. So... Linking. Well, it's working. It compiled. And it worked. I don't get it. Oh, I think I get it. It's probably because I had the serializer open before I refreshed the project. So let me open this. Yeah, now it's good. Okay. So we have this. Actually, let me have something about this. I don't really like how I just have blocks here. Why do I have the animation time again? Yeah, I'm not using this. This is a bit obsolete. So let's remove that. And anim. Yeah, let's remove this. This was when I first created the project. I didn't know how it worked, so this was like the base example. It's nice to see this. It just shows me how far I've come, and you know, that's like kind of sweet. So this is the first way to store a chunk, right? You basically store every block of the chunk. That can work, but I want to split this into cube chunk. Memory, storage, cube chunk storage, and full cube store. Well, compact. What is compact? What is the opposite of compact? Antonym. Compact antonym. Loose, diffuse, spacious, scattered. Okay. Word that describes an array containing everything. Well, representing a grid. Oh, I guess grid is fine. A metric, well. Lookup table. Oh, I guess technically it's a lookup table, right? Well, I guess if we want to have a name that describes how it is really well, it's like array cube chunk storage, because it's just an array. It's just gonna be an array there. And we're gonna have the storage for now, which is going to be like this. Okay. And what we want is we actually want to serialize the storage. It's actually the storage we want to serialize. I know I'm repeating myself just a little, but actually it's the storage we want to serialize. That's crazy, I know. So now it also makes it a bit more clean to serialize and deserialize, because our data is like very limited, right? Storage. Actually, I mean, no, that's not good. Wait a second. Well, okay, we're gonna have multiple things. That's not enough. Because we do need the size of the chunk too, right? So we do need this in the end. Okay. Well, it's not gonna compile because of the change though, but that's fine. So now we have cube chunk. We have the NV blocks. I guess we can store the amount every time, because it's like not a lot, right? So we have NV blocks. And when we serialize, actually does Godot have like a serializer? Godot serializer. Object serializer, that's not really what I want. Var to string and string to var. Text conversion. I want binary var to bytes. Oh. Packed byte array. So var to bytes. What about C++? What? Oh, actually I could use the JSON. Maybe JSON would be better, because across computers I want the data to be good. Built-in binary serialization, utility functions. It's creating a variant. I don't like that. It's like basically the class that is used for GDScript, but we are using C++, so we don't need to be so abstract. JSON and text. I mean, this is good too. But I don't know about network. Technically, I could save it in binary JSON, something like that. Resource saver and resource loader for objects, no. Well, no, I don't think so. Saving loading. Native C++ libraries. No, then JSON. I've used this a lot. Protobuf. I've used this one too, but I don't like it. Let me binary serialization. What is that? For objects versus object instance IDs. Packet specification. Always padded to 4 bytes. All values are little endian encoded. All packets have a 4 bytes header representing an integer, specifying the type of data. Okay. So yeah, it's basically the type, right? Oh, it's not supported. Yeah, that makes sense. 3 different ways as null. With full objects equal false. Or with full what? Oh, okay. Dictionary, array, packed. Do I want things to be blazingly fast, or do I want them to be safe? Because I think that's the main difference. If I want it to be blazingly fast, then my chunk is going to be packed, and is always going to have the same order of data, right? For example, we store the amount of blocks first, and then every block, right? But if we use something like JSON or binary JSON, then we can have something a bit more safe, where, for example, we don't need the same order every time. And we could also scale it to different kind of versions, to different versions. You could have a version tag, for example, and read it and handle things differently depending on the version. So that would be nice too. I think I might want a mix of both. Like I want JSON overall, but for this, basically for this, I want a packed binary thing, probably. So does Godot have a JSON serializer? Godot JSON serializer. Object serializer. Let me C++. A variant, JSON. Oh, JSON stringify. Wait, this is not bad. Okay, we can go from here. So we have the JSON. Actually, we need to include something, I think. Well, okay, yes, the wrong header. JSON. Core IO JSON. Wait, there are multiple files. Okay, it's third party. Core IO JSON. Core IO JSON. Here we go. Resource format. Then you go in. Token type. Oh, I like that. Wait. I don't like that. It's a resource, but it has a lot of static functions. So we have parse, we have stringify. So what is it using? Stringify. What is this using? Dictionary. Full precision. I'm not sure about that. Let me go with GPT for better context. So, Godot CPP serializing chunks. Using Godot, how can I serialize it efficiently? Serialize it into binary JSON, for example, and have a custom serialization for a specific type. I don't think I can because we just saw that it was switching things there. So it's gonna be a bit difficult. For chunks, I will not use JSON. Custom binary serializer. Godot variant serialization, var to bytes, bytes to var. And load. Yeah. Custom binary format. Yeah, that's something I want, right? PHP vibe coder. I'm not really... Is it vibe coding? I'm not really vibe coding. I'm getting advice that I can turn down, right? I'm not sure I don't want this. Yeah, that's the version, right? Well, I mean, I guess if I start with the version, then I can switch. Wait, what is even file access? What if I want to send it through the network? I can't do that, right? I have to serialize it into bytes. Custom serialization. Wait, I can implement my own serialization methods. Okay, I'm gonna... Wait. Yeah, I don't care about that. Yeah, the version is important. Okay, let me just check something. Is there any class that has a custom serialization function? It seems like there is. Let me check in other places than the debugger. GLTF, no. Multiplayer. Debugger. Server. Is it just a function that is automatically called? Oh man, I'm searching old CDs right now. Popped in an audio CD and attempted to play it. Closed the media player and the music kept playing. I was so confused. It was your background music. That's fun. I want to see what the string would look like. Cow data. I mean, I do want a binary. It's kind of a shame that there's no binary JSON serialization, because there's literally this file that actually doesn't. Never mind. Yeah, anyways. So what are we gonna do? Well. Okay, let's try this. No, let's not. I wanted to have something like JSON to like wait, can I convert to binary? Wait. I mean, I guess Stringify is good enough. Then we have something like a dictionary. Type dictionary, maybe? Okay, I suppose. That's going to be from what? K, what is K? What even is K? I guess it's a string name. From a string name to a value. Yeah, I don't know about that. A value. And it's going to be chunk. I mean, I do want bytes in the end. Chunk data. Then we can do something like, oh right, we can have something like position, well, size equal this. We can have, why is it not working? Incomplete type. Okay, so if I remember correctly, it's like core variant type dictionary. Perfect. Here we go. We set the size, like NB blocks maybe. Okay, then we are gonna set our blocks, and this time it's gonna be a bit different because it's actually going to be a packed, well, it's going to be bytes, right? So bytes. We're gonna have something like the format also, and the format is going to be, right, string name, let's say, and it's array, well, let me go back here. Array cube chunk storage, let's say. Bytes, so the bytes. Anyways, after that, yeah, I'm just gonna ignore this. We're gonna stringify, I suppose. That means I'm copying the data 2 times, right? Like, I mean, I can't even reserve the string. That's alright, maybe. Yeah, let's not think too much about this kind of performance right now. Yeah, let's not think about performance right now. bytes. So bytes, we're gonna have serialize, I suppose. Well, serialize this. Storage. We have the blocks. And it's going to be a bit special because we need the database. We need the database. Do we? Actually, maybe we might serialize the database. Let me think. That could be an idea. So we could have something like, wait, name to voxel, type. And then we have integer to, yeah, okay. Wow, okay. So, voxel proxy, and we have external voxel db, we could say. And this is going to be, maybe just storage. Maybe storage would be, nah. Well, mapping. Voxel database mapping. External mapping. Mapping maybe is fine. And we're basically going to assign for each block, for each string name, right? We're going to assign the index. So I guess it's the opposite actually. For each index, we are going to assign the type, which is going to be like this. So it's ID to block type. Or like to block name. Okay. And we need this here. We need this here. So technically we need a bit more than just the chunk and the bytes and stuff, right? Let me think. Serialize. So we want to serialize with... Well, we want to serialize with a name. Can I have... Wait. Something like... voxel... I guess voxel mapping. Yeah, it's not really a database, it's just mapping. Voxel mapping map name. I guess it's a map. I'm changing this every 2 seconds. So it should have like a name to be able to be identified, or like a GUID technically. And this is gonna be... Well, this should be like an argument of the serialization. Or actually it should be like just... Can I just do voxel db? VoxelDB. Well, just name, basically. Or like version ID. Yeah, just ID actually, it's an ID. Should the ID be a name or... I think a name is for the best. Let's just say, yeah, that's it. That's gonna be it. Boop, this is an ID. And by default, it's just gonna be called... Well, I have no idea. Something like 0. I don't know. Well, VoxelDB 0, something like that. I don't really care. So yeah, I have to get the singleton. Get singleton. And now I can get the ID. Actually, is this already here? Or ID? Not really. I don't really like ID because it's a bit too generic, right? But let's say it's fine. So ID, we get the ID, we set I guess it's an idea actually. And then we want, well, we just want to serialize, right? So we are going to do something like, what is going to be the maximum? Okay, I just need the mapping, voxel map. I'm gonna have this. And it's important because that way we can compress our data. Like, for example, an integer is 4 bytes, right? But if we have only like 10 types of blocks, we don't need to store an integer for all the blocks, right? We can store like just, I guess for 10 it would be like 4, like 4 bits, so like 1 byte. I mean, it would be too much even. Wait, no. 4 bits. Wait. 1, 2... So 4. Wait. 2 power 2, 4. Wait. Eight, 16. Yeah, it's power 4. Wait. No, wait. I'm getting confused. Yeah. It's power 4, so it's 4 bits, I guess. For 16 block types. So, we're gonna have this, and we want ID to block name. We just want to get the size, actually. It's just the size that matters. And the reason for that is, well, it's just what I explained, right? NB blocks. Well, NB block types. And now it's basically going to be... So wait, we have this. How can I get the closest power of 2 that is higher than that? Because I feel like there's an algorithm or something that's like efficient. I guess I just have to get, well, the leading one, I was gonna say, but if the rest is not 0, then it goes up. Well, get closest power of 2 that's above. Math approach. Oh, the log. Yeah, the log, I guess. The bitwise approach. Hey, for integers. Okay. Well, okay. I guess you can just do things manually. I guess it's simple too. If it's less or equal to 0. Yeah, it shouldn't be, right? But okay. And minus minus. Wait. You minus minus. Oh, yeah, because you want to get the... yeah, okay, that's fine. So n... or... wait, what? Wait, you're just adding everything, right? Wait. Populates all bits to the right of the most significant bit with 1s. Then adds 1 to roll it over to the next power of 2. Oh, wait, that's... oh! All bits to the right. How is it to the right? Wait, I don't get it. How is it to the right? Or equal bitwise. Running up. Yeah, I guess it's running up. C++, running up, nearest power of 2. Oh, wait, actually there's this. Well, no, find the nearest. No. Between hacks. You need to get the base 2 algorithm, then add 1 to that. Compute the next highest power of 2, then now. Of V. Wait, I don't get why it's stopping magically. Oh, wait. Some explanation. Let's check this. I'm interested. Divide by 2 power k for consecutive doublings of k. No? Wait. The result is a number of 1 bits equal to the... well, yeah, you understand like the end. Here's a more concrete example. Let's take 2 to 1, which is this in binary. What? Oh, well. So minus minus, okay. You go to, you get this. Then you do the OR. So you have more 1s. Then you have all 1s. Then you continue with all 1s. And then you do plus plus. There's 1 bit in the nth position. Yeah, so how is it? How do you get... oh, wait. Huh? Wait, that's not how it works. What? Wait, but the OR is... isn't it supposed to also work for like the rest? These other bits? Like, why is... like, before this was 0, right? Why is it not 1? That doesn't make any sense. I guess it's something I didn't know about OR, maybe? Wait. What if it starts with a 0? That's my problem. Because right now it starts with 1, so of course it's going to round up correctly. But what if it starts with 1? It doesn't make any sense. Yeah, this is good enough for me. Oh. Oh! This can reverse. I don't want flats. I don't want this kind of stuff. Everything sucks. Okay. I'm gonna ask GPT for an explanation. C++ fast. Well, fast round up nearest power of 2 plus explanations. Yeah, so it's the answer it gives, right? Suppose you have this. Minus, minus, you have this. Okay, so it starts with a 0. I like that. So no, so you have all ones, right? Finally. No, that's not what you do. You have this too, right? No, that's not what you do. Alternatives. Wait, you have that in C++20? That's crazy. Wait, I love that. I want that because yeah, they're like the C++ standard is supposed to be optimized on, for each compiler depending on like the platform, right? So if there are specific instructions for the target platform that can make it fast, then yeah, I want that. I wish I would be able to use C++20, can I? Can I just include bit? And do something like std bit fail. It doesn't exist. I don't think I have it. C++ bit. You know what? I'm going to change the version, I think. So everything is C++29? That's the first time I see about this. Without the possibility of undefined behavior. That's what? That sounds like bullshit. That sounds like bullshit. Expands bits from an apparent using a mask. That sounds like bullshit. Oh, this is so bullshit. Oh, this is so bullshit. Wait, I want to say about C++29. That seems crazy. That seems incredible. Where is it? Extension support? No. Maybe in C++? Or this. And C++. Oh, 29. So what happens in 29? So 26, I'm not familiar with 26. You have contracts, okay. Your headers, okay. Well, okay. Linear algebra. Okay. You have meta. Oh, you have meta. Okay. SIM. Yeah, this one is. I love it. I love it because SIMD wasn't. It was platform specific. It's always been. But with 26, C++ 26. It seems like we can finally have something that's like platform agnostic. So I love this. I love this. Okay, I don't even know what this is. RCU. What is that? Fred support. What? RCU domain. What is RCU? To be protected by RCU. What is RCU? I don't know what RCU is, but I guess it's some kind of mutex kind of stuff. Barrier. Okay. Text encoding. Oh, you have format. You have formatting. Do you? Okay, more text support. That's good. I like that, I suppose. I mean, it's gonna be the C++ version, right? I'm not sure about this, but okay. And 29, I want to say about, well, 26 is this. Trivial union, reflection. Reflection? Library features. Format, SCD format, yay. Here we go. Well, it's just using something that already exists, I guess, but that's fine. Hazard pointer, what is that? Wait, what is that? FTM. Safe reclamation. Oh, wait. Oh, that's for... Okay. To be hazard protectable. So it's for threads, basically, multi-threading, maybe. I don't... This is crazy. Exception pointer cast. Okay, what is 29? What is it reserving for us? Compiler support, no. 29. So, embed, contracts for virtual functions, coroutine, promise, library features, deprecating signed character types. Oh, good. Thread attributes, pointer tagging. Wait, pointer tagging, FTM. Yeah, what is FTM? It seems like everything is FTM related. Better lookup function for map content. Yes! Well, wait. What is that? Try and place. Better lookups for map and flat map. What is flat map? Oh, it's map inside a vector. It's like a binary tree, contiguous binary tree. Probably. The container is const. And now, to use the find member function, which returns an iterator. Yeah. Special Python of a lookup member function that returns optional. Okay. I'm not sure about the optional. Okay. Like the maybe facilities. Wait, that's I want to read about the maybe. And a concept to constrain maybes. Yeah, what is maybe? What is a maybe? Maybe concept. The concepts maybe requiring this. Yeah, I can't read this. This is C++. This is the new C++. Yield if. Right, you have this too now. This is crazy. Okay. Wait. So FTM, what is FTM? I don't know what FTM is. Wait. C++ 29, what is FTM? Feature test macro. It's a preprocessor macro used to check if a specific language or library feature is supported. Right! They talked about this. Right. It gives a date value. Right, so it's to make updates more flexible, I guess. Okay. Anyways, let's not look more of this. We don't really need this. What I just wanted is C++20. Can I have C++20, please? Debugging. No. Maybe there. No. Good do. Oh, it's going to rebuild everything though, if I change the version. Is it? Wait. Godot C++ engine specify C++ version. Because I think it's actually scons. Is it here? A custom module. Yeah, that's it. That's what I was thinking about. And adding CSS flags. Yeah, okay. So I'm gonna do this. It's in SC_sub. Okay, SC_sub. We can do that. Let's go there. And we're gonna have add source files. Yeah, I have this. Source files. Yeah. And module endpoints happen, so we have the flags, CC flags equal. And I guess I want another flag. And the other flag is gonna be... Technically I can reuse this, I guess. And std equal C++20. Can I? If I regenerate, is it gonna work? Wait, I can't. Okay. Regenerate. Okay, is it gonna be good? I want to use Bitsale because this seems pretty powerful. This seems pretty good. And after we use this, NB block types, so we have the amount of bytes. Bitsale, okay? Like NB bits, maybe? Oh, actually, it's not really the amount of bits. It's just the sale, right? Oh, wait. Then I guess the algorithm might be a bit different. Maybe I just don't need C++20, actually. Well. Well, yeah, I guess it's not about sailing. So, what about find minimum amount of bits to store integer efficiently? Yeah, kind of. Based on count leading 0. Okay, std. So it's still in bit. So we do have this count L 0. And you do minus because you inverse, right? Got it, got it. Seems good. Not choose like 2. Yeah, I mean, I want performance. Godot has its own helpers. Yeah. Yeah, that makes sense. Okay, I like this. Reload. Save. Okay, are we going to have access to the function? Please. std bit. Can I go in? This is actually... Wait. Has CSS20 0, so it's a nope. Godot C++ module specify C++ version. You check there. Oh, there's a slash here. And there's something else there. Target C++ 20. Wait. GCC and Clang. Oh, but I'm using MSVC. So I guess I need a slash instead. Can I check the other SC sub? And do something like this. With... I mean, SC sub isn't really there though. Let me open the project again. But like this. And we're gonna have this. It might take some time. Just a bit of time. Please! Oh! Mason, what is this? What is this? This is not what I asked for. Oh, well, it's me, alright. So I mean, obviously, I don't really want this. I don't want to find my own class. But in the build we have... Oh, it's third party though. Wait, so this is a bit weird. This is a bit... not good. Go to C++. Custom modules in C++. So, version. Libs. Let me check SC sub actually. Specify version. Specify C++ version. I have no idea. I guess it's a slash if it's MSVC and that's it. I don't really like this, but... Module and that is MSVC. Can I just do that? I guess it's happened. Well, it's happened. Can I just do that? If it's MSVC, I do something. So CC... Oh, it's not CC flags, it's CXX flags. That's one of the problems. And else, so we have the slash there. STD this. And if it's GCC or Clang, it's with a dash equal. And that should be fine. CXX flags. Should be alright, please. Please be alright. Let's try this. I really want to use standard the standard library whenever I can, because the goal of the standard library is to be optimized and to work, which is not the case with GPT and my own code. My goal is to be fast. So if I can delegate things, then it's for the best, right? That's why I'm using Godot in the first place. So we're gonna have this, we're gonna have the amount of bits. So then we can have this point resize and initialized to the amount of bits times the amount of blocks. So storage point blocks point size. Wait, that's the amount of bits though. And 1 byte is 8 bits. So I guess we're gonna round up, I suppose. So I guess it's plus 7 divided by 8 to have the amount of bytes. So we have NB bytes like this. And here we go. It's still billing. Oh no, it's not. Wait, there's a problem. It didn't find his MSVC. Okay, good. I knew it wouldn't. So I'm just gonna be bad, and I'm gonna do that. Can I actually have this 2 times? Well, if not, I'm just gonna have this, and that's gonna be it. It's gonna be good. Let's rebuild it. And let's hope it works well. So we have the amount of bytes and we do this. Okay, good. Now what we're gonna do is for each block. Wait, that's gonna be... Wait, what's that? Unterminated string natural. Right. There. So now I feel like it's going to be a bit tricky. I'm actually not used to that. Wait. Do I have to bit shift every time? Well, that kind of sucks. C++ write bits inside byte array. Well, right. Not directly bits, it's copy bits into byte array. Maybe actually there's a class for that. There's something called something. Safe and efficient bit copying. I don't like that. Bit writer. Well, okay. Fixed style macro. For single bit manipulation. Yeah, it's single bit manipulation though. Bitset. Yeah, bitset I guess is the best. If it's compile time constant, it's not. Okay. Okay. I've had. So we have this equal true. Endian swap. Hmm. Shiva Cross are enough. Ah. No, it's not. Pack data into bits array. Can I do that? Bits. STDC out bits. Oh. Wait. Well, I know that std vector is specialized for booleans. To just be like a single bit. But yeah, that's for booleans, right? Standard size bit set. It's not like that. Manual low level bit packing. Yeah, I think I have to make my loop myself. Byte position. What? Expand buffer if we cross a new byte boundary. Extract the if bit from the value. Pack it into the target byte position. Do I really want to pack things right now? Max value to ensure it doesn't exceed the requested bit width. I mean, let's say we have chunks of 50, 50, 50. That means we have all of this, okay? Let's say each block is 4 bytes. That leads us to, well, bytes we said. Well, yeah, let's say this is 4. So we have this, right? When it would only be this if we packed things. Just by packing, we reduce by, you know, like we divide by 4 the costs. So I don't want to do that. Seems pretty good. So we have the value, we have the amount of bits. And max value to ensure. Yeah, okay, this is fine. Then bits. So yeah, it's, the maximum value is -1. Okay. Well, this -1. So then we have that. It's not working for if it's like the max value of an int. That's why it's a size T, I guess. That makes sense. Okay. For each bit in 9 bits. Wait. Right. Yeah, I mean, yeah, you just do things manually. Okay, no, I understand that. Yeah, no, okay, this is actually pretty simple. Pack it into the target byte position. Buffer. Wait, buffer is... What is buffer? It's a std vector. And you have the bit position. Right. That makes sense. Bit index ++. And if it exceeds this, then we have the byte position. Okay, yeah, I mean, we basically just split between bit and bytes. Okay, wait, do we have like the bit thing? Let me check. What was it again? Okay, so... I mean, yeah, I just said I don't need this, actually. Well, okay, that was a bit useless. Wow. Wow. No. So NB bytes. Bytes or bits? Well, bits first. NB bits is like 32 minus count L 0, it doesn't exist. And it's still not there. Contents of bits are available only with C++20 and later. I don't like that. I just don't like that. It's just not working. Is it? Like, actually, if I do... I don't think it is... Well, you know what? The only way to know is to try. Count 0. So we have the value, which is the size. Or like, never mind. It's NV block types. NV minus. Okay, 32 minus this. I guess it's unsigned. So it's U. Everything here is U. And for... Well, yeah, let's just do something with this. Let's just try this. Because we're gonna have a bunch of errors because of the storage thing. But I guess we should be able to see if this works or not. Because it's gonna try to compile chunk serializer, right? Oh, it might include other things. Okay. Now, blocks. I don't have any problem about STD, the thing, right? So that's not bad. Okay, for now I'm just gonna do this. I'm just gonna access the storage. Am I? I guess I am. Oh, this one is a bit different. So resize is fine because it's like the generation, but so it's about the storage. But this one is a bit different. We just want to set a voxel, right? Wait, so let me go back in kubechunk something. Kubechunk actually. So now it's storage. Okay. GD set local block. So what about this? Set local block. Do I have anything here? Emit signal. Oh, that's why I didn't do that. Okay, this is good. Set local block. Get block index. Well, set voxel unsafe. Maybe. I mean, this is not really good. Well, let's do that. And it's gonna be kind of the same, probably. But we don't call the callback. So it's basically this. Oh. Local cards, type. We can remove this. So now we have set voxel unsafe. And yeah, instead of setting this is so bad. Generator. Yeah, it's in the generator too. Well, good enough. Instead of this, we just have the coordinates. And we have the voxel. There. Okay, something like this. Blocks. I mean, I should be able to get, well, at a specific index. Oh yeah, this one is broken too. I shouldn't use the index, I should use coordinates. That's why I have my bug if I spam click. References. Blocks. I can have, I don't actually need this. Texture ID. It's basically just a get, wait, cube index. Oh, create uniform, wait, what? What is that about? Quad index. Index. I don't care. I really don't care. For now, I just don't care. Actually, wait a second. Voxels. So this is the span, okay. Yeah. And you do things. I mean, okay, let's just start again. Serializer, I just want to see if this function compiles or not. And there wasn't any compilation error due to that before. So I'm hopeful. I am full of hope. Wait, what is that? Overriding OD with O2 for optimization. Good. Maybe. And then we have overriding C++ 17 with C++ 20. Perfect. Perfect. That's good. That's what I want. And now we just have those things. Which is fine. Is opaque. Do I want that? I guess that's fine. This one is get block index. Ew. Yeah, we can make it a bit better. We can do a get local block from the local cube cards. So basically from this, right? And now we can just check if this is opaque. Okay. So this is good and it should be compiling. Maybe. Serializer. I still can't go in, but that's fine. I think it's because for the solution it's C++ 17, but for my module it's C++ 20, so it has like some problem getting the right macro. But this is fine, is it? Undeclared identifier. Well. I guess I was actually using this a lot. It's fine as long as it's inside cube chunk. Oh. Good enough. Okay, let's try again. Ideally, I want my storage to not be part of the class, I think. But that's good, that's fine. Or maybe a union. A union could be nice. Yeah, a union could actually be good. Because I need an array anyways for my voxels, right? So I'm gonna have pointers. Building, okay, and it works. It works perfect, perfect, perfect. Let me just verify that it actually works, maybe. That I can actually just play the game and have it be the same as before. I don't want like a random crash or something like that. Okay, it seems to work well. Can break, I can place. I even have my entities. I have my animations. Yeah, I have everything I want. Good. Oh, thanks for the follow, mister. Hello, hello. Welcome, welcome. Are you curious about what I'm doing? Do you want to... Like, if you want to see anything, if you want to see the game, just let me know and, you know, I can show you, I can... yeah, I can explain you and stuff. Oh wait, it's time for the good music. Let's increase the volume. Okay, good. I hope it's not too loud. Should be good. So. Wait, what? Get set. Get block. Oh. Yeah. Oh, well, actually, I'm not even calling this class anymore, am I? Yeah, I'm not even calling this anymore. That's fine. So what we're gonna do? Well, the goal right now is to be able to save chunks, right? Like Minecraft chunks. And we have this. We have the amount of bytes. And we can reserve the amount of, well, with the amount of bytes, right? So now we need a loop. That is going to loop over every... Actually, I guess maybe we can have a while. Can we? Well, no, let's just loop over the storage. So we're gonna have the block, which is this. This point blocks. Like voxel, actually it should be. So we have the voxel, which is a voxel proxy, right? So let me just go back there. It's a voxel proxy. And we have an int inside, that's the ID. Can I just get the ID? How can I just get the ID, actually? I can't get it. Wait, how am I supposed to... Oh, it's friend with voxeldb, that's why. I don't want that. Wait. Yeah, but I'm already... Well. I guess we can have this. Get ID. It's const. And it's just returning ID. Okay. So now we have get ID. And we want to serialize this. But we don't want to just serialize the full integer. We just want to serialize bits, basically. So we have current byte equals 0. We have current bit equals 0. Maybe. It could be this, technically. But yeah, I mean, technically it can be this. Okay. So now what are we gonna do? We want to put this inside out bytes. So we have the current byte. And I guess for every bit, do I have to do that? Do I have to loop over bits? Maybe I do. So for this, a bit in, well, equals 0, bits is less than NB bits. Whoa. Here we go. So we have bits plus plus. Oh, yep. Well, yeah, actually. So we have this. Wait, no, it's not. Wait. So, wait, so we have the ID. I'm getting a bit tired. My brain can't work. So bit equals 0, bit is less than the amount of bits. So basically we want to copy every bit there. Well, we want to do... We have the voxel, we have the ID. So what we do is ID and the bit, right? And we want to add it to the current bit, like this. Wait, so we end. Wait, so we end. Wait, no, we end. We did. Technically, no. Well, technically, it should be something like this. With an end with 1. So basically, end 1 new. And so what we do is we have... Oh, Superxen, hello, Axaver. So basically we have a number, right? What we do is if like the bit is, we're trying to treat like the second bit, so bit equal 1. Then what we do is we push it to the right, like this, right? And then we end with 1, so it does this, okay? And then what I want is I want to, so I'm doing a OR, right? So this is current bit. Yeah, so this is actually ID bit. And we have current bit. That's going to be pushed the other way, I think. Something like this. So that's ID bit. Okay. Yeah, it's becoming a bit difficult, but that's fine. And what we need is every time we add something here, we are going to do current bits plus plus. We want to go to the next bit. But if this is equal to To what actually? To 32, I guess? I guess. 32. Then we set this to 0. So unsigned, let me just put unsigned. And byte plus plus. We go to the next byte. That's it. Wait, that's for... Wait a second. No, because bytes... Well, that's a byte. That's not a uint 32. That's just 8. That's just 8. And current byte. Yeah, this one is good. Okay, yeah, this should be good. So yeah, this should work, right? It should be good. Okay. So we write everything into out bytes efficiently. We pack things together, taking the max size into account. Yeah. Okay. We don't have to return because we directly resize and assign. And yeah, I guess it's fine. I guess that's it. I guess that's it. So now I just want the deserialization function to potentially make unit tests to make sure this is working as I intended to work. So yeah, that's the kind of function that should have a unit test. Definitely. So we are gonna have the byte, we have the map, and we have the storage. So I'm just inverting this. Out storage. Boop. Okay. So I can... Yeah, let me just check something. So I need the amount of bits, the amount of bytes, you know, that kind of stuff. And then I need to add it there. I guess we can have the idea of each block. Like, I actually have no idea how to do things. Oh, no, that can be pretty simple, actually. No, that's gonna be pretty simple. Is it? Well, I guess in some way. Because we can resize this to what? Wait, I actually don't have enough data for that. I need the size. Huh. Let's assume it's good. Let's assume it's already resized correctly. Okay. Well. Yeah, I can't. Technically, I could compute it from the bits, but... Actually, that's not a bad idea if I want to assert in the first place. So I have the amount of bytes. I have the amount of block types. Wait. So I can have I can use the opposite formula because I have bytes. So it's basically bytes equal this, and bytes times storage size plus 7. I'm gonna do some pseudocode. So I have this. So I can multiply by 8. Yeah, now I can do a -7. And then I can divide by storage size, something like that. No, not storage size, by the amount of bits. I can technically have something like this and retrieve the storage size. But then there's just a problem with truncation. I think it's fine if the truncation is in this way. So this should be something like this, and we should be able to resize like this. Maybe. NB bytes. Yeah. I mean, I already have this though. It's just bytes point size. What is that? Wait, what? Oh no. Oh, right. It's size. I just said it. So we can have something like this. We can set. And then out storage. Let me increase the volume. I feel like you can't hear anything. Okay. So we have all of this. Now we want to go through what? Yeah, through... Yeah, how should I loop? For every block or for every bit? I guess it doesn't actually matter. I guess I can go through every block. So resize uninitialized. How is it gonna... Can I use that? I hope. We have the proxy. There. We have current byte and current bit. And we are gonna get bytes point... Well, we're gonna get the current byte. And then we have the current bit. So the current bit is going to be end. Current bit. Wait, I'm doing this. Yeah, it's basically gonna be the same thing, right? So I can do this with a end 1. And then the goal is to move it back. So I have to do that for every bit. Yeah, it's basically the same loop. Well, it's basically the same, right? Well, actually, it's gonna be a bit different, but yeah. So we have ID bit, I suppose, yeah. We do this, and then we move it back. Move it back there. And I'm just gonna have proxy, well, we have the voxel ID equals 0, it's important, 0U. Then we do the OR, so we can add to this correctly. Wait, current bit. Yeah, so I want to increase this. And now I do the same. If it's equal to 8, then I reset this to 0 and I increase the amount of, like, the index of the byte. And yeah, it should technically be good. Yeah, it's good. Should be good. It's really the same. So I just want to set the ID, I suppose. Do I want to set the ID? Well. I mean, I guess there's also going to be the map, right? But we at least want to convert things back to integers. I'm not sure how fast this is gonna be. Technically, it's just like bit operations, but you know, I can't help but be a bit unsure about this. Because I have an if, right? Technically, I could do a modulo, but modulo is still expensive. Set ID, let me just do this. And outbyte. It's just... Wait. Yeah, wait. Wait, what? Yeah, I don't want that. Deserialize. Should be good. Yeah, I mean, I'm resizing ahead of time too, so it's not as if I'm gonna have like a ton of allocations. Well, for a single chunk, it's fine. I'm not sure about the network, but it should be alright, I hope. So... I want a unit test. Where was my test? Okay, my tests were there. Voxel conversion. Can I add a new one? If I check my... Wait, run tests. Wait, what? I guess I can just copy this. Can I? And call it tests. So not voxel conversion, but test something else. Voxel serialization. Okay. Let's go to the... Oh, there's no header. Oh, right. Let's regenerate the project. And let me check this. I forgot. Yeah, I need a specific name, but it's like the name of the file, so I can have voxel serialization there. And voxel conversion, I don't really care about this. I mean, I can remove a few tests. And this is going to be voxel serialization. Cube chunk serialization. Okay. Yeah. So now, we have all of that, we remove this, and we just have the serialization. So we have the cube chunk. Or actually, never mind, we don't actually have this. We just need... Oh, right. Well, it can just be a class, I suppose, or like a struct. I suppose it's a struct. And voxel map is a class, maybe? Actually, I have no idea. Voxel database. I guess it's a struct. So many structs. So now I need to include modules, core, chunks, cube chunk. with the database, so modules voxel core database. Wait, that's in the serializer. Yeah, I mean, okay, never mind, that makes sense. Okay. So now I include, okay, the serializer. I'm gonna include modules chunk, core chunks, cube chunk. So what am I going to do first? Technically, it's like static, right? I don't actually need references. So I can do chunk serializer. Serialize from a cube chunk to bytes. Oh. Cube chunk. Like this, and local vector out bytes. There. Good. I just need to create. I can just do a menu, right? Technically. Yeah. Okay. I mean, I don't even need the cube chunk, do I? Like, if I go inside, I have the amount of blocks. Oh, never mind. Oh, yeah, I guess it's actually needed. Oh, right. Well. Well. No, it's not needed. I can just have the storage. Okay, let's just have the storage. That way we don't have to handle nodes and that kind of stuff. So serialize the storage, and we need the map though. So the map is a voxel map. Voxel map. ID to block name. Let's just add a bunch of bullshit. I could even use the random function. Yeah, I can't have a push actually. So it's indexed to string name. So let's say 0 equal grass. Then we have 1 equal ton. 2 equal diamond. It doesn't really matter. And now the storage is gonna be a random between those, well, all those values. Maybe 0 is actually air. Yeah, 0 is actually air. So, storage. Wait, I don't actually even care about the amount of blocks inside. Okay, so let's do I equals 0, I is less than 24, I plus plus. Yeah, I guess I just want to serialize indices, really. Well, indices, well, integers, like an array, a single array. I can abstract this. So 24. I'm gonna do something very simple. Storage blocks I equal I modulo 4. That way it fits inside this. Can I just... oh. I can't even set the ID. Oh wait, that was the problem. That's what I forgot to do. Set ID. And we have, well, in ID. And ID equal in ID. So that's what I was missing. I set the out, but here I don't. I just update the voxel ID. And at the end, I should set the ID. Good. Yeah. So I do this, I set the ID. Does that work? Const. The object has type qualifiers that are not compatible. Is it because of blocks? Oh no. Right. Oh no. And span is gonna be like storage point blocks point span is const. Wait, what is const? Is it the span or is it what's inside? Can I do this and, for example, have that, well, for example, I. No, I can't set. That's what I thought. So let's do PTR right and voxel proxy. Voxels, we call this. Here we go. And now we can set technically, right? Right? Well, it's okay, is this? Okay, good. Now we can. Good, good, good. So we modulo 4. Why do we do that actually? Oh, right, it's arbitrary. Well, it's basically if I want to not be arbitrary, then I should do this. Then I serialize. And I have out bytes, and then I deserialize. So bytes should be first. Yeah, I mean, I guess it's bytes, right? The map is next, and the storage is last. And let's have out storage, I guess. Maybe. And at the end, we want to compare the storage. We want to ensure that every block of the storage is the same. So we have, what was it? This. Check equal. We want to check that the length is equal. That's the first thing. With storage and out storage. Like this. Maybe it's not going to be... No, it should be equal. No, that should be fine. Maybe? Well... Yeah, it should be fine. So we check if this is equal, and then I equals 0, I is less than... I mean, is it a check, or is it a must-have? I think it's a must-have, really. What is it then? It's require equal. We require that this is equal. And then we check that this is equal. Wait, so let me copy this. So we have do this with I, and we ensure that this is equal, like that. Okay, and it should be fine. Wait, check equal, it's... If it's true, then it doesn't do anything, right? It should be good. Okay. So now, how can I have this? Do I have to refresh this maybe? Do I have to test Explorer? No, it's not there. So I guess I just have to run the bats. Wait. Voxel. Wait, where is it? Oh, is that? Yeah, no, mind. Run tests. Everything inside. Well, everything that contains voxel. Okay. Do I have... Oh, I may have to build. It's regenerating things anyways, but I don't think it's actually going to regenerate anything. Yeah, it just finished and it doesn't change anything. So, compiling, I guess I modified a few things. Maybe? Maybe not. Why is it compiling everything? That's a bit weird. Because of the include, I guess. Linking. Good, good. Link, link. And done. Good. Reload. Okay. And now we're going to run the bat. So can I actually open the command line and do run tests point bat? Oh, bucket large. Paged allocator. Huh? What is that? Wait, that's a bit weird. Nav mesh geometry parser 3D were leaked. Huh? Leaked. Wait, how is it possible? Oh, is it because with C++20 it's a different thing? But yeah, what test is it? Test case is 5, 4 passed, 1 failed. Voxel is... Oh, is there? No, man. I just have to look here. Program crashed. Set ID. Oh. Okay, well. I don't know what this is about, but yeah, this is definitely more of a problem. Test voxel serialization 22. This. Set. Wait. Oh, it's because of the resize. I have to resize. So let's do something like resize uninitialized 24, maybe. We build and then we are going to run again. Require, yeah, okay, this is fine. Is it? I mean, I should check this, but I should also check actually the storage. Well, no, this is our storage. Never mind. Yeah, okay, no, this is fine. Okay, so we have this. Let's try again. Huh. Cow get. Please include this, no. P index equals 0 is out of bound. What do you mean out of bounds? So it's line 30 this time. So it's a bit different, isn't it? Oh, it's because it's not equal. Oh, okay, so now the condition is wrong. It's not a crash. Good, it's because of me. So 21 and 0. Why is it 0? Why is this 0? It's supposed to be out. Oh, okay. Right, I'm not assigning it. I'm not putting it in the function. That's why. Compiling. Let's get ready. 3, 2, 1. Link. And... Oh, it's link? Okay. Okay, I just finished. Now we have... What do we have? 21. 21 is out of bounds. So 24 and 21. Okay, so there's still a mismatch, but now it's, you know, a bit better. A bit closer, right? So yeah, I guess by default it's 24, and for some reason it becomes 21. Can I actually debug this? I should be able to debug this. Serialize, deserialize. I mean, I know it's just the amount of blocks for now. So it should be with the computation, with how I'm computing things. Let's take an example. I have... So my example is... I can store everything into 4 bytes. 4 bits. Oh, thanks, Clooney, for the raid. Hello, hello. Hello, hello. Welcome. Welcome, people. We're trying to save chunks, which is a bit important for like a voxel game, I suppose. And I'm trying to serialize it efficiently. I guess I don't really, it's not a priority to do it efficiently, but you know, I just want to have a bit of fun, I suppose, on one way. But I feel like if I don't do that now, I'm never gonna do it. So yeah. Hello, hello. So we're doing beat things. We're compressing the beats. The main idea is that right now, my voxels, well, my chunks are made out of blocks that are represented by a proxy. Each block is a proxy. That is just an integer, an int32. But the thing is, if I only have, for example, 16 different block types, I don't need the whole int32 range, right? So the goal is to compress that. Like if I only have like 16 block types, then it's basically just 4, so 2 bits is 4 possibilities. 3 bits is times 2, 8. And 4 bits is 16. So it's basically, I only need 4 bits. And I want to compress all of that information when I'm serializing it. So serializing both for saving, so it takes less space on the disk, but also for networking, so it takes less bandwidth when, you know, like networking, like in multiplier when you want to load a new chunk from the server. When you want to get the chunk from the server. Okay. Guess that's it. Namespace, std. Well, yeah, well, basically we did the serialization, but we have a little problem. And the problem is that, well, we made a unit test to ensure that this is working well, that the deserialization is the same as, you know, it's like the opposite of the serialization in a one-to-one way. It's like one-to-one. So we have our little test functions there, test macros from Godot, and it tells us that the size is not the same. So we want to retrieve the same size. So why is it not the same? Okay, so first we get the amount of leading bits, and then we do a minus. So let's say we have 1. That means we have 31 leading zeros. And if I do 32 minus 31, it's like 1, it's 1 bit. So this is working. Now NV bytes. I'm also using C++ 20. That's why Visual Studio doesn't really like this IntelliSense. Then the amount of bytes. So let's say I have 1 bit in total, like to store 1 ID. Then I do this times the size, the total amount of blocks I want. So times, for example, 256. Or let's do something like abstract, like 50. Okay. Then we do a +7. And we divide by 8. So this leads us to 57 divided by 8, which is going to be 48, 56. So 7? Wait, is it 7? 28, 56? Yeah, it's 7. Wait, 14, 28, 56. Yeah, 7. So 8 times 7 equals 56. Wait, no, that's not what I do. Wait, no, wait. Wow. Well. So basically, yeah, the result is NV bytes equals... Wait, equals what? Equals 7. And that's the results. Now we want the opposite. We want to retrieve the amount of blocks from the amount of bytes. So what we have is below. Let's say we start with this is 7. So we have something like 7 times 8. This gives us 56. And we do... Wait a second, -7? Yeah, of course that's not gonna work. This leads us to 49 instead of 50. Wait. Because there was a truncation. So I guess I might just want to divide by the amount of bits. I mean, the amount of bits was supposed to be 1. Wait. Can I even retrieve this? Yeah, I can. I just divide by... I'm actually not sure. Yeah, I mean, in this case it's a bit tricky because NV bits is 1. So I can't even use this to retrieve the right amount, the right size. I guess I need a size outside of this. Yeah, it's like impossible to retrieve the right amount of bytes. Now that I think a bit more about it. Not of bytes, the amount of blocks. Because of the padding. We pad, but that's it, right? So I guess we need to know the amount of blocks. Got it? Wait, any bytes? Let me remove this. So now we have this, I can remove. And instead of this, we're just gonna have storage size, maybe. Good enough. So how do you save chunks? I have my blocks, and I put them on the disk. Well, not really. Well, basically the goal. Well, basically my chunks are represented by an array of voxel proxies, so of integers. It's basically just integers. Right, so let me show you. So I basically have, it's supposed to be a 3D array because X, Y, Z, but in practice it's just a 1D array, right? It's just a simple vector. So we have for example 1, which is, well, for example 0 is air, 1 is going to be grass, 3 is supposed to be maybe wood, 0 is air again, and 2 is going to be bedrock, for example. Okay, so we have this. Now the thing is, I don't want to save my integers as they are. I don't want to, because, for example, if I only have 8 different block types. Let me think. Yeah, if I only have 8 different block types, then I don't need to save an integer with 32 bits. Because 32 bits is 2 power 32. It's like, that's many possibilities, right? So we don't need that many possibilities because we only have 8 possibilities. And the goal is to save as few bits as possible. So we are just going to save 8 bits for one value instead, right? So this is simple. 8 is simple because it's like 1 byte. But instead of like 1 byte, we could instead have something like 7 bits. Or we could have something like, I was gonna say 12 bits, no. But like 10 bits maybe, right? Which is a bit more of a problem. Because it's not, it doesn't round to a byte. Like to an amount of bytes. So yeah, basically we have that. And that's what those functions are about, serialize and deserialize. And now I'm trying to test them. So I have my unit tests, which is trying to serialize this dummy chunk, you could say. And then I'm trying to deserialize the chunk. And I'm comparing the output to the input. Because my serialize function should be like the deserialize function should undo the serialize function. That's it. So now we have the storage size. Yeah, that's something I came up with. Basically, you need to have the size of the storage. Because you're adding some padding. Because, yeah, we want to save bits, right? But in the end, we still need to align it to bytes. So we need some padding at the end so that it fills the bytes, right? And that means we need the actual size of the array there. Because we don't know because of the padding. So NB blocks, let's do NB voxels equal 24. That's arbitrary, but that's fine. And we have this. Okay, let's try again. And then we're gonna run the unit test again. Hopefully this is good this time, because this was 24, and this one 21. This was 21. Do I still have the minus? Wait. Oh, no, that's not what I want. Okay, now this is what I want. Redefinition, yeah. So let's do that. And let me just put a comment. Serializes voxels into as few bits as possible. And pads the end to finish the byte. And then we have serializes. Deserializes bytes into voxel data, we could say. And we have requires storage size because we can't compute it because of the padding. Okay. And now we want to run the unit test. Failed. Check equal. Okay, well, the size is the same, that's normal. But check equal, why? What is that? What is that? Oh, wait, I forgot to set resize uninitialize. No, that's not it. Serialize, voxel serialization. I set this. I mean, wait, storage voxels. Wait, what? Wait, what? Huh? I mean, I guess it's fine. Is it? Should I do something like this to ensure that... Well, I mean, it's not gonna change anything, never mind. Wait, so what's the problem with this? With the world also load faster than before. It's not about loading the world. Like, before, the loading was due to the generation. I only generated the world. It wasn't saved. It's not... I don't have any file that specifies... Well, I mean, I guess I'm gonna run my unit test, so I don't want to run the game. But, yeah, it was generated. It wasn't loaded. So, I mean, technically it should load it faster, I guess. Well, if the chunk is already saved, then I think it should load it faster, because when you generate, you have like a bunch of data that you have to compute, right? Like chunk generator, this? No. Chunk generator, cube chunk, this. Right, you have like a bunch of data. You have to find the biome the block is in. You have to... Well, I guess this is already a lot. You have to compute the 8th, right? Like the 8th map. A bunch of things. So yeah, this should be faster too. But I guess... Well, I mean, I guess it's like different operations. One is about computation, so, you know, the CPU. And the other one is about loading from the disk. I think it's what's going to take the most time. But it should still be faster. It kind of depends on your computer, that means, but it should still be faster in general. Because I'm still like computing noise a lot of times for the 8th map and for the biome. So yeah. Well, yeah. I mean, yeah. And you know, custom conditions and that kind of stuff. So we have this. What then? What do we have then? Deserialize. Yeah, right. So why is it not working? Check equal. Oh! Wait, I have 113 assertions and 111 passed. That means most passed. Wait, 111? It's supposed to be 24. Wait, what? Wait, what is that? I mean, it should be in VVoxels. Well, I mean, okay. 24. What? Oh. No, it's because of my other thing, probably. Wait, so this one, let's just check this. So this is not correct. Check equal. So what are the values? I can't see them. I don't know why. And I run this. Yeah, so I don't actually have more errors than that. Wait, it's only 2 times? Or maybe that's like kind of... Maybe those are just 2 values. Or there. Maybe it's failing to set the final things. I don't know. I want to add a message. Can I have a message? Check fast. Catch for backward compatibility. Okay. Require a message. 1. Let me check my conversion here. We have check equal. Do I have any message? I don't. Go to C++ unit test. Check ec message. Check equal message. Check message. Wait. Option 1, option 2. Oh, info. Oh. Yeah, but this is going to be printed in any case, right? So I guess what I want is just check message. So here. So basically I haven't really talked about why I want to serialize things. But I mean, in the first place, like, yeah, that's like kind of important, like if you want the player to break blocks and stuff, right? But the actual reason I wanted to do that is because once I have serialization, that means I can save specific structures and I can just sample them. Well, I can just sample from them to generate my dungeon. So if I want to generate like specific rooms in my dungeon, for example, I can just like create the room ahead of time and then sample from it. That's the reason. It's because it's supposed to be kind of core to my game, because I also want to be like to let the player create its own weapon, that kind of stuff, right? So there are actually multiple reasons. And the message is gonna be... Ah, you see. Oh, never mind. It's just moving. So, I... Can I just put I? Well, no, I need... Wait, check message. Can I check this? I need a value. Mesh not found. Technically, it's VA args, right? So I can put as many things as I want. And I should be able to pass variables too, right? Hopefully. So let's just put I, maybe. I want to see what index is failing. Technically, I could also just build debug, but that's fine. Well, no, it's better that way, I guess. Linking. Yeah, and I mean, the generation is pretty fast right now because the reason it's pretty fast now is because I've split my code into different modules, and the generation module is always optimized right now. And I can still debug my other modules if I want to. Wait, so now it's good? Oh, now it's not good. Wait, what? It's good sometimes, but not always. What is that? So it's because of uninitialized things. Is it? Wait. Wait, if I run again. Now it's good. Huh? Huh? That doesn't make any sense. When I start again. Okay. So logged 0, logged 21. So 0 is the first index and 21 is the last index. What are the values? So index this. Then we have something like values. I mean, it's supposed to show the values, right? If it's like this question mark, then it's because it's like invalid, I suppose. Is it? Then we have this one. Okay, let's try like that. It should only be like the test module, so it should be pretty fast. 0 and 21. I want to check the other things too. Compiling tests. Linking. Go. Wait, so it is not valid. For some reason. Index 0, 21. Yeah, I mean, it should at least display integers if it was... Oh, no, I know why. Oh! It's because it's trying to show voxel proxy, not the ID. Right. Oh, that's why. So I don't need this. What I really want is... Well, what I can do, I guess, is get ID. I could also add like the operator to displays, like the flow, the stream operator. I could add the stream operator there in voxel proxy to display it. Anyways, so now we should be able to see the IDs. And aside from this, yeah, I mean, I guess that's it. Gonna be pretty good. 2, 3 to 1. Done building targets. Okay, so now we have, okay, so we have it. 0 equal 1. Wait, so it's outputting 1, okay. Actually, is the order correct? Yeah, I think the order is correct. Then we check. 1 equals 7. So 0 and 21 are always... Wait, actually we have more now. Oh no, we have everything. Everything is wrong. 7, 3, 7, 6, 3, 3, 3, 3. I don't even have... Oh no, I do have 3. But I don't have 7. Wait, so... I mean, this is obviously wrong. Oh, 2 seconds. My apologies. I mean, it would be great if I could just finish this before the end of the stream. Oh, it's already like 3 AM. I just realized. Yeah, let's just finish this before the end of the stream because it should be pretty simple. We should be able to actually debug this. Let's go there. Let's go there. So we have editor right now, but instead of editor, we can actually have... let's open the bat file. Run tests. And we have this basically. Tests and this. Well, all of this, I guess. So let's start. Let's remove editor and replace it by this. And let's go in test voxel serialization and let's go here. Let's go here. Breakpoints and let's wait. Let's just wait. Okay, so first I want to check if this looks good. 0, 1, 2, 3, 0, 1, 2, 3. Okay, this looks as expected. Good. So now when I serialize... Oh, it's optimized. So 3 bits. Because 8 is it. Like I only have like 4 types. So... I mean, technically it should be... Wait. 1 bit is 2. 2 bits is 4. So technically it should only be 2 bits. Not 3. So I guess we have our first problem. Wait, NB bits. Wait. NB block types. Can I... Oh, it's optimized. So yeah, this is a size of 4. Oh, so I guess that's why I need the -1. I mean, yeah, well. Yeah, I mean, that makes sense. -1. And now it should be a bit better. Or maybe that's why it was wrong before. Let me restart. Actually... Building targets. Can I run this here? Before it starts? Done. No. Well, okay, yeah. So let's go in. I only have 4 block types. So now it's gonna be 2. Yeah, now it's good. if I need 2 bits to represent everything, then that means if the amount of blocks is 24, that means I need 48 bits. So we multiply, and 48, and then we align, basically. Wait, so 48. And I guess it's a perfect product. I can't even see this, actually. Oh, that, I don't like that. I can't debug this. It's optimized out for some reason. Let me check. No, I don't have anything about this. I don't have like a CS tab. MD bytes, can I watch? Well, it's undefined. Okay, so what if I do this? Okay, so we have 6. If we do 6 times 8, so that gives us 48, which is completely matching this. Okay, so yeah, it's like perfect. So 48, we resize, and we start at 0, we get the ID. So I guess it's 0 at first. So I mean, it's gonna do stuff, and that's it, we have 2 bits. Okay. Yeah. So then we continue. Wait, ID bit is 2? But it's only supposed to continue if it's less. Wait, what? Wait, what is that? False. Huh? Yeah, that's what I thought. So we loop again. Second voxel. This time current bit is 2. Byte is 0, good. So wait, this is supposed to be 1. So we have 1. We shift 0. So it's still 1. Then we end, so it's still 1. And then we shift 2. So if I check this, we have, so 1, 2, 4. Okay, so it's shifted correctly. I mean, it should be good now. I mean, it should serialize it correctly. I guess the serialization is good, that means. Okay, so I mean, okay, serialization is good. Let's check the serialization. So here, the amount of bits. Wait, this one is gonna be wrong too. Yeah, okay, this one is wrong. Yeah, I need to fix this. Let's restart. Oh, Kalani, sorry I got distracted. Is your project going smoothly? Yeah. Well, I gave up on the battle for now. Because I want some progress. Like, I was stagnating, and I think something important when you make a game, and like, you know, that is going to, like a big game, you could say, is that you need motivation. No, not the battle. Yeah. Wait, what? Oh, I guess it just finished. Let me just put the breakpoints. there. Yeah, you need motivation. So I decided that if I do something and I have multiple streams without any visual progress, without a progress that can be seen in the game, like in-game, then I need to go do something else and have it be visible. Okay, so now the amount of bits. Well, I guess you can't really see that, right? Like serialization, you can't really see that. But the goal is, well, for testing, the thing is that I'm gonna be able to, for example, copy chunks. So I'm gonna be able to see the result of that pretty easily. And then I'll be able to like create rooms for my dungeon. And I will be able to generate those rooms inside my dungeon from this, basically, thanks to the serializer. So this is the goal. This is the goal of the serializer. And the results should be, you know, you can, but you should be able to see it at the end. Maybe not in this stream, but yeah. I mean, it shouldn't be too hard. Next stream, probably. It's already 3 AM, that's why I'm saying that, I guess. So, NB bits, 2. Okay, this is good. Storage size, 24. We have 24 blocks, that's good. Bytes should be 48. Is it? Well, 48, so it's like 8 times 6. Wait, 8 times 6. 12, 24, 48. Yeah, this is good. 48 bits. So we continue, we resize. Good. Probably. Wait, is it the right thing? Yeah, okay. Is array storage. So now we have proxy. We have the first ID, the first voxel ID. We go there. Oh, wait. Something might be wrong. So this one is 0. So you get the first bit. Wait, it's like 2 to 8 every time. Yeah, I mean, I guess that makes sense. So we shift to the right. Then we end. And then we shift back. So 0. Wait, what was that? What the fuck? Huh? Wait. Wait a second. Huh? Huh? Oh, so it is going in. Okay, well, I'm not sure what happened, but okay. Alright, I sometimes forget to live 6 hours in the future. Yeah, I live in the future. Prepare yourself. Well, I mean, I can help you prepare yourself because I know the future. So... Why is it 100 and... That doesn't make any sense. I mean, I guess it's not initialized. It just keeps everything. Is it that optimized? Or it's big... Oh. Is it trying to convert 0 into... Oh. That's why it's 112. Because 112 is basically almost half of 256. So it's like signed. We have the signed 0. Okay, so what if I do 0 here? Like 0u, I mean. Should be good, right? Oh, I mean, I guess... Is it good? Can I try again? Let's try. C++ is just... C++ is just trolling me. Or Visual Studio, I don't know. Linking. If... Okay, so now we have this and ID bit. And this is... Wait, this is not 0. I don't get it. Okay, I guess it's supposed to be a character. Do I need to cast? Do I need anything? Wait. You mean... Do I need... I don't know. I don't get it. Do you? That doesn't make any sense, does it? Like, can I go there? I can't even breakpoint. Oh, because it's optimized. So maybe it's actually good. Maybe it's good already. Current bit 6. Yeah, I think it's good. I don't know either. Yeah, no, it's just optimized out. So I can't debug. That's pretty bad. Let me first see the blocks I have. What? I guess it's optimized. Wait. Proxy. Can I just do that? Struct at null. This is the problem, isn't it? Struct at null. What do you mean? I have a resize there. And I just can't... Oh! Magic. Woo! No. I know. It's because it's a vector. And when I loop, I'm not supposed to set the data, I think. That's why. It's like copying things, probably. That sucks. So let's do out voxels, maybe. Okay, let's do that. So we have blocks, points, right, pointer right. And it's going to be this. Out voxels. And now we can loop. We can't. Shit. That's interesting. I can't use a span either, right? Okay. Let's do something like... Let's just have integrals. I is less than the size. I could use pointers too, it should be better, but I'm used to integrals. I mean, never mind. We can have this. So we have the proxy equal out. Then we have proxy while this is not equal to this plus the size. Then we plus and we just use the arrow here. That way we don't have to, we don't need another line to have voxel proxy. Is it still really hot in Japan? I mean, basically there's a lot of typhoons, so it's a bit, you know, less hot than usual. But yeah, I don't know if having like a lot of typhoon is that good, because like just tonight actually, well, that's why I started the stream a bit late, is because my electricity just shut down. Electricity and water. And, you know, not just for me, but like for the whole area. So I think it was because of the typhoon. I mean, I don't really see what it could be other than that. Maybe it's just a coincidence too, because I don't think it was very noisy, very powerful near me. That's crazy. I mean, it was not, you know, like for a long time. So, you know, maybe it was just something stupid, like a bird eating like a cable or something. I don't know. I don't think it's supposed to happen, but we never know. So that's our lies. Okay, now. Yeah. Okay, oh, storage. This is 0. Okay, so second proxy. What is this? Oh, it voxels? No. Well, this. Wait. Blocks. So this is 1. Okay, okay. And when I get to the end, we have... This is not the end. When we go there, we have blocks. And this is working. This is working. Oh, this is so good. Oh, I love it. And now this should be succeeding. So if I run this again from the terminal, 1 time, 2 times, as many times as I want, it's like working every time. Maybe not. Wait. Oh no. 2 equals 3 is not correct. Wait. 1 equals 3. Wait, how is it not good? So summer isn't the best time to come in Japan. To come to Japan? No. Oh, definitely not. Definitely not. It's not necessarily about the heat. It's about the humidity. Because it's so humid that it feels hotter than what it actually is. I mean, it can still get pretty hot, but yeah. Well, I mean, you know, I was just talking about typhoons, right? So, yeah, I guess it gets a bit humid with typhoons. Wait, let me try again. Fail. So sometimes there is an offset. I mean, I don't have any random though. This is so weird. Index 2. This is so weird. And I mean, the index is good. That's what's crazy. Is that it's between, it's like not a random number, it's like something valid that's inside the map. So should I resize any, well, resize uninitialized? Set ID. What about here? I have a local vector. It's a local vector, so it's fine. I don't have cow. It should be valid. Should I print everything? I think I should print everything. Yep. Oh, that's gonna be a pain, actually. I mean, I guess not if I just print the IDs. So what was it? It was info, like info. Something info. Doc test. No, I don't want doc test. Where am I? I'm there. No. Oh, just info, maybe. So my info is gonna be... What is it gonna be, huh? Can I just show a vector directly? Like... Do something like... Info... This. And then do the same here. Without storage. Just build. And then run this again. I don't know if it's gonna work. I hope Godot has some overloads or something like that for arrays. But I'm not very helpful. I don't have a lot of help. Doctors info because it's calling this. And yeah. Yeah, it's not working. It's not correct. Wait. Let me verify Godot C++ unit test. So, well, print array. It's not print, it's show array in console. I think it's just info. Okay, this is wrong. Zaya is wrong. This is just info. It should be info. So we are gonna have... Well, I mean, technically, I kind of already have this. Right? So 2 equals 3, so 2. 4, 5. So this is good in between, though. That's what's a bit weird. I feel like I'm forgetting 2 increments, maybe. Oh, I think that's the reason. Serializer. I'm forgetting something. If it's 8, then I do this. Never mind, I don't know. I don't know. This... Yeah, let me just see. What I want is for voxel voxel proxy in this. Then I want info. Or maybe I can just have like a string. S1. So for example, this plus equal proxy get ID is to str, so maybe str. Wait, str. Well, let's see, the two string should work, right? It's not good, but it's fine. And then we have this. Well, then we add backline. Why is it not good? Oh, right, it's not a string, that's why. Wait, can I... Oh, right. It's not an STD string, so there might be something already for this. Like an operator. Like... Maybe. Yeah, we have this. There's already an overload. Good, 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 good. So we have this, we have the plus, that. We do that, and then we show S1. And then we do the same for S2. So that could be a function, really. That's fine. I don't actually need the... I don't actually need this, because info should already be doing this. That's fine. Okay, so let's see how it looks like. Let's see how the output actually looks like. I think it's gonna help us a lot. I'm so glad I'm making those unit tests, because it would be such a pain if I didn't. I still don't... Oh! Okay, so I have something displayed. But... but yeah, that's it. Values. Check 0 equal 1. Logged. A bunch of stuff. Index 0. I don't get that. 52. Oh, no, that makes... Does that make sense? That doesn't make any sense. Well. Well, it kind of does, though. Okay, never mind. Well. Oh, yeah, it just needs integrals. No, that makes sense. I have 2 lines and... Okay, that makes sense. I just need this to be... good. And it's not. It's just not. Plus equal. What is it supposed to do? Latin. So it's trying to converse, right? Yeah, okay, that's the problem. Oh, okay, okay. So what I want is string to, well, maybe int. Like, not to int. It's from, wait. So how am I supposed to do that? Go to C++ int to string. Num, oh, num. Ew, that's a double? Well, I guess I can have that. Here we go. So now. No. I build. I build. And we should be good. Oh, wait. No, I don't have that for the other one. Okay, let's build again. I just want to finish this because I still want to run the test with the command line, as long as it's not blocking, to see if it at least shows. Yeah, it shows something good. So the first one, 0, 1, 2, 3. Yeah, it's good. The serialization is, well, never mind. It's how we initialize the array. So, I mean, that was good in the first place, I guess. Okay. And what is the result? I want to see what the deserialization is. Because it should be pretty apparent. Wait, what? 20. So this is equal all the way up until... Wait, what? It is equal. Oh, wrong one. Let's build again. My bad. You can also make storage to string. That's gonna take the storage, and that's going to return a string. Return S1. So now we just have to do this with the storage there, and then the out storage. And technically it should be good. Maybe. Let's just test this. Let's actually build. Okay, good. Well, not good. That's what I want. It starts at 2. Yeah, it's completely broken. What is that? It's completely broken. Wait, it's so loud. Okay. So yeah, why is it doing that? Because the first one should like be valid. Like, that's something really simple to check. Like, I can just go in deserialize and, you know, just check, right? I should show the bits. How can I show the bits? Okay. Let's do... Whoa, my eye. So bits str equal nothing. Then... I mean, yeah, I can just have something very simple. For storage. Well. No, it's out. Well, bytes. So this bytes in byte. Do I want to loop over every bit? I guess. So if... Well, bit, I said. Yeah, I mean, this is a simple way to do things. I feel like, so... Bit. Equals 0, bit is less than 8. I don't need the u in 32, that's fine. Bit plus plus. And I want to... Whoop. I want to wait, byte. Yeah. Bit. I'm gonna get the beat, which is a end. And if this is 0, I'm just adding the test, but technically I don't really have to. Is it this? Yeah. If this is 0, then I want to add, wait, end. Wait, is it? No, 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 no. No, wait. That's not an end. That's one. Okay. It's one. Like this. Is it? Yeah, it is. So we bit shift. So we can loop through the byte. And then we end every time. And is it going to be in the right order though? I feel like this is going to be reversed. That's fine. You know what? That's fine. 3 plus equals 0, and else we're gonna add 1. And let's say this is it, right? Let's say this is it. I mean, technically, maybe that's like the reason my code is not working. No, 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 it's not working because something is undefined. Yeah, I don't know what is undefined. I mean, it's only sometimes also. Because it's good in a lot of cases. I mean, it's just like Minecraft, I hate it. Wait, what? What was that? He wrote Minecraft, everybody knows that. Oh, you're right. When he was in prison, right? I remember. I was a guard. I'm the reason you have creepers in Minecraft. Yeah, he was jailed for drawing bad. What is that alternate reality? That's crazy. Oh. I think I'm starting to get tired. Let me run this. Wait, I'm not printing this. Never mind. Info. Let's build again. We have bits str, and now it's good. That's why I never draw. How do you been? You already managed soft body physics? Well, not in this project, but I did some soft body physics before. On stream, actually. So I should be able to... I mean, I did it in 2D, I think. So I guess in 3D it's gonna be a bit more difficult. Yeah, definitely. Wow. But yeah. Let's see how it goes. Please fail. Good. What the fuck? Wait, what? Interesting. Why is it 1? I mean, it's returning 3, 3, 3, 3, 3. So that makes sense. Yeah, okay, now it's different. So 0, 1. Oh, it's reversed. Then we have 2. Wait, what? Wait, it shouldn't be like that. 2 should be 0, 1 in this case. Probably. Maybe. Why do boxes interact with each other? Like they're made of foam? What? Boxes? What do you mean? With soft body physics? Or like my boxes? Solid foam, I mean. Huh? Wait. What? What do you mean? You know what? I don't know. I don't know, that's why. Let me start at 7. And when it's higher than 0, then we minus. So it's going to be like this. That way it will be, it's going to be in the right order, maybe. Is it? I don't know. I actually don't know. In Half-Life 2 game, when you stack a bunch of boxes, they start jiggling like crazy, then explode. Oh, like they waste nothing. Why do they behave like that? It's because of, how do you call that again? Of constraints resolves. It's because it's trying to resolve constraints and it's not working. Because it's not something you compute perfectly if you want to do it in real time. How to make it better? You can't. That's why you still have people trying to do some physics stuff. But I mean, no, you have ways to improve that. Why am I complaining again? So basically you're talking about, well, basically when you're simulating physics, you have different objects that are under the influence of different forces, right? And, you know, you compute the forces, you compute the velocity and stuff, and at the end they have like a velocity vector, right? For example. And then, you know, the goal is to move each object, right? But the problem is that you can move this object and then this object, but then they're going to collide. So you need to split them, right? And that's kind of the goal of the constraint resolution. And I guess you have different ways to improve it. Like, for example, when you detect a collision, you're trying to compute different colliding points so that like you can have like some kind of surface, I don't know, and try to split things and try to optimize a bit like that. What if it not move them instantly? What? I mean, if it doesn't move them, it's gonna try to... I mean, it's basically the code, right, that you're writing, but if you're not separating them, then they're just going to be at the same place at the same time, right? So it's not a collision. So what you usually do is you slowly move them out to, you know, as a debug thing. But then, like, if you have a lot of boxes onto each other, well, one on another, right? Then the box that is in the middle is going to, well, it's not going to know whether it should go up or down. Because, like, there's a box down, there's a box up. So it's going to be, you know, jittering, right? Why ragdolls always act like they're with nothing? It's not about ragdolls. It's about the gravity, it's about the acceleration you put on them. So it's a choice. If they wave, well, if it looks like if it looks like okay, I'm gonna say it. If it looks like they waste nothing, it's because the acceleration applied is not that big, probably. It's a choice. Wait, so 0. Wait, let me try again. Please fail. Okay, good. What the fuck? It's supposed to be 0, right? So I think I was wrong. I think it was the right direction. Yeah, it was the right direction. Let's build again and let's go up. So this is our example. The question is, so for some reason this is 2. No, this is supposed to be 1. Yeah, why is it 1? It's not supposed to be 1. It doesn't make any sense. And why sometimes it's working and sometimes not? Did you know there are 3D engines written in Scratch? I didn't. I've heard about, well, I mean, I guess you could call them engine. But I've heard, yeah, about a few things, like a few big projects made with Scratch. But I forgot. I just forgot. And I'm not sure about the performance. I mean, it's like impressive, I guess. Well, is it? I don't know. Well, I haven't coded in Scratch, so I can't really say much. I don't know the language. I don't know what's possible. Why is it working most of the time? Serializer. It's supposed to be always the same. Oh, wait. Oh, I know. Oh no, it's because outbytes is uninitialized, that's why. Oh, stupid me. That's why the bytes are wrong too. It should be initialized. Because, yeah, I was doing this, right? But this requires the initial thing to be 0. Well. Yeah, I mean, if I want to make things a bit more clean, I could, well, I can resize uninitialized. And let me cancel. Then I do what? Wait. Never mind. I need this. Okay, should be good. Yeah, okay, that's why some values were random. It's because it was random. It was good sometimes, because sometimes the value was just 0. It was just 0. Or like, when it wasn't 0. Well, basically the zeros were at the right place. And I had a bunch of ones in my... Well, I have a bunch of ones in my output anyways. So it just had to align. Let's go. 1, 2, 3, 4, 5, 6, 7. I said it. Okay, now it's working. Now there's no random value anymore. Okay, so it's working. We have our serialization. And this is really good because... I mean, for multiple reasons. Is that streamer, can I ask? Yeah, sure. But basically right now we are... Like in our test, for example, we have 24 blocks and it only requires 48 bits, which is basically... How many bytes? 7 bytes. 7 bytes for... Actually, let's try something. Let's try this. So we have an actual idea of how well it can optimize. So let's add a bit more than that. Sorry, I'm gonna read your comment. I just want to test with something that looks credible. 24. No, maybe 100. And we have padding. Let's try this. How about game engine review? The game engine I wrote. Oh, like you want me to review your engine? I mean, I could review your engine. That could be nice. I don't know if I should make a video about it or if something simple, like a quick review, is good enough. And maybe a video would be nice. But, I mean, that depends. I mean... I'm not sure how much time it would take. I would have to see the code. Because it could be, like, really fast. Just on stream. Short review. Yeah, I mean, I could do that. I could also do that during the stream and just like cut it into like a dedicated video. I don't know. Oh, that would mean I would have to download the stream and I don't have enough space on my computer for that. And like literally. Okay, so here we go. Okay, is the volume alright? I'm so nervous. Okay. So it's time to review the engine that Repet did. So first, the bad thing is you don't have a readme, so I have no idea what this is about. I have no idea about how the code is organized, but I mean, we don't really care, do we? I mean, it's your engine. So, I mean, the first thing I need to know to give correct feedback on your engine is... What's the goal of your engine? Is the goal to make a game? Is it to learn about engines? Is it to learn about a specific engine feature? Is it to... You know, what is the goal? Is it a collection of tools, or is it like with an editor? Is it just play around maybe a 5-minute game in the end? Wait, what? Oh, yeah, okay, that's a goal. Yeah. I hope the volume is alright. Okay, so let's open assets, core packages, git ignore, build point batch. I don't know about this language, so I'm gonna believe you on this. Odin, GLSL, I know GLSL, that's the only thing I know, and it amounts for very little. So I mean, I should be able to understand, though, Odin. So assets, models, shaders, okay. So do you have an editor? I guess you don't. I guess it's just an engine without the editor. So, I mean, the first thing I see is, you know, usually you split your, well, usually you have your engine and then you have your game. So my first question would be, how are you going to run the engine with your game? Is it like a library? Is it like a, is it a dynamic library? Is it like a static library? Nuts. Oh, nuts. Oh, well, okay. Oh, you have this. You know, if you name it readme, then it appears directly here. But maybe that wasn't the point. It's all just an exe for now. Makes sense? Okay. I mean, if you wanna go fast, it's like the fastest thing, I guess. I mean, I guess my first feedback would be about that, really. Usually you want to split because you have dependencies too. I didn't plan to show it to anybody. Yeah, that's good. So then we have core. I mean, really, it's not really an engine. TOML, oh, so it's like for parsing TOML, right? But yeah, I would say it's not really an engine. Or like it's lacking some stuff, right? Is it? Actor. Wait, let me just open everything. You have level. I mean, I guess it's, okay, maybe it's an engine, but like a minimal engine. So you have your level with like different things, with multiple cameras. That has like a dictionary from a string to the camera. So I guess the name, from the name to the camera, maybe? I don't know, I don't know this language. Dynamic, interactable. So you have a list of interactables, of spawn positions and stuff. So it's like hard-coded. It's like a game. I didn't plan to, well, yeah. It's like a game, it's like hard-coded. Right? Gameplay cameras. Okay, so your okay. Your create function is pretty big, so I would recommend you to split it even more. Like, I mean, I got multiple recommendations for this. Like, you have some people that say your function should only be 25 lines maximum. Some others say that it should be... like, a function should have one function, basically. Should do one thing. Split even more, yeah. Like, for example, you have, like, strings points to Lua. It shouldn't be in create level. Like, your create level function shouldn't be aware of, like, string operations. Really. Like, maybe, loading the room, loading the room name, maybe that's fine. Right, that should be fine in creating the level, but yeah, it shouldn't be like this big loop. Like, usually I would say if you have a loop, like a big loop, it can be a function on its own. Anyways, so Shouldn't use this. Okay. Wait, so actor. What is actor? Okay, so I guess you have an object-oriented approach. Because you have like the speed in... Well, I mean, actually, it's really... Well, I mean, yeah, it's object-oriented because I don't see in your files any system, right? Well, you do have a model. So, I mean, I guess it depends, right? But it makes sense. Like for rendering, you kind of have to send the buffer to the rendering API. Bounding box. Vector state. Input. Yeah, basically the problem with having something like this is that if you neck rotation? I don't know what approach this is. Well, basically, well, I'm gonna explain. So basically you have an actor, right? And actually, let me check your camera, but... Yeah, just a camera, okay. So you have an actor, right? Your actor has a bounding box, has a model, and do you have collisions in your engine? Yeah, my actor rotates its neck when he interacts with interactable objects, okay. Oh, you only have one actor. Oh, the actor is basically the player, is that it? I was thinking of the actor as in, you know, Unreal Engine's actor, which is basically the base class for every well, everything you want to place in your worlds, in your sim, in your level. Actor is a player, yeah. Oh, okay, got it. A character, got it. Well, I mean, I guess the first feedback I can give then is it's gonna be a pain if you want to well, I mean, a pain. Well, you just have to implement the system, right? But like, if you want to make a collision system or like a physics system or that kind of stuff, or even like wait, so interactables, what is that? Does that have like a mesh? Because you're not... Because you have like a mesh for the actor, right? For the player. But what about the interactable? What can you see in your engine? No, I don't want collision system. Yeah, I mean, I'm talking in general. It might not be a collision system, but for example, for the rendering. But yeah, now I'm thinking about the rendering. That's why I'm asking this. Level. Room. Or point model. Yeah, I don't know what R is, but okay, I guess your level itself has a model. R is Raylib. Oh, okay. Oh, right, it's there. Got it. Oh, right, so you're using Raylib. Right. So I guess Raylib takes care of like the rendering, and you have to create levels. So... But you have to create level. Depending on the arguments. Right. Yeah, okay. Yeah, you have a table. So you load from Toml or JSON or something. Okay. And you have a list of levels and you load one level at a time. Leak. So yeah, where are you registering? Like if you do... Oh no. R points. Loads model. Okay. Okay, so it's here. You load the model. So when are you displaying it though? I'm not very familiar with Raylib. But is it like automatically added to the rendering, or do you have to like add it explicitly with a function? Oh, you have the bounding box, BB. Actor update post, nah. Core point Odin. Oh, okay, my bad. So core point Odin is the core. Got it. Oh. So you have a bunch of global variables. I mean, that's something I wouldn't recommend. I mean, if you want to go fast, it's, you know, it's a way, I guess. It's one way. Load shader. Get shader location. Load font. So you basically load everything. I mean, you have that in the main too. Usually what you want is a resource manager, right? I mean, I guess R is Raylib. Never mind. I guess it's actually Raylib is actually already the resource manager. Well, not well. Well, no. No, you load the shader from. Okay, yeah, you have your path. But like, you know, it's always. Well, I don't know actually. I mean, basically, you want usually a resource manager because you don't just do everything here like that, right? Like, if you want different shaders for different objects, then, you know, you might want to set it from the game side instead of the engine side, like you do here. Because on the game side, you might want to add additional shaders, right? Like in Godot, you might want to create a shader for your watcher, for example. And that means you want to, you know, load your shader. And what's... I mean, actually, do you have to... I mean, I guess you might want to also optimize the format and stuff of your assets. Like with points meta files, for example. But I mean, that's fine. Defer. What is defer? Does that mean it's like asynchronous? Is it just like dispatching a task, basically? I guess it's dispatching a task. Is it? I suppose it is. Free all. Temp oh, okay, to optimize, got it. Every frame. What is dispatching a task? Well, basically, like, I guess in engines you have task systems, usually. It just really handles a bunch of stuff. Oh, okay. Well, basically well, are you familiar with multi-threading? Like in multi-threading, you have multiple threads because, you know, each thread basically runs on another CPU, right? On another unit. And you can basically dispatch and do multiple actions like in parallel, right? So you can, for example, on one CPU, I don't know if it's actually a CPU, processor maybe. On one processor, you can, well, in my case, that's a good example. For my game, On one processor, you can generate the terrain. On another processor, you can I don't know, render the terrain, right? On another, you can generate the collisions, that kind of stuff, right? And usually you want to abstract this a little because the goal is to use threads as much as possible. So you don't actually want a render thread and a collision thread and that kind of stuff. What you want is you want to split your code into tasks that can be, that are units that are, well, small units, you could say. Well, still maybe big. And you basically want to run the task on a thread. But then, thanks to the task manager, you're going to have multiple tasks on the same thread, like one after the other, that are not related to each other. That might be, like, one might be about collisions, one might be about generation, one might be about whatever. And it just runs on the same thread. It's just basically using the thread as well as it can. Didn't use it here. Yeah, I know you didn't use it yourself, but when you defer, it's basically saying probably that you are doing an action asynchronously. I think. Let me actually check this. Odin defer. Like, for example, in C++, you have std async that does that. That dispatches task, basically. Or maybe not. No, maybe not. Block scope based. Or maybe not. Wait. Schedules a line of code, a block of code to run automatically at the end of the current scope. Oh, okay, it's that kind of stuff. I see. Oh, so it defers until the end of the scope. Got it. I get it. Right. Oh, right. So that's why you defer unload. I get it. Okay, so I see what it does. Never mind. Defer just means run in the end of the scope. Yeah, I see what it is. Okay. I mean, good enough. Begin drawing. Oh, so you have it's basically OpenGL, like old OpenGL. I mean, maybe it's like batching behind the hood, right? Probably it is. Well, batching. It's basically optimized behind the hood. But it's just a rendering from Raylib, I guess. Good enough. Draw a walking area. Workstate machine again, yeah. Well, basically my feedback would be, well, it's not really an engine. I see what you mean by that, but I think it's a game more that, well, it's a game more than an engine. And like most of the engine part is actually handled by Raylib. So it's like just a game. Like just a simulation. I mean, like deciding if something is a game or an engine, like, in the end it's just words, right? It's just categories. In the end you have some code, and I would say you don't have a lot of engine features coded in your game. You basically have your main loop, right? That's why you call it an engine, I suppose. But, outside of that, you have your objects. You render your objects manually, but yeah. So it's just a design project. I mean, I wouldn't know how to call it. I would call that like maybe a prototype to test your not physics, but your, how did you call that? I forgot. Right. But yeah, it's lacking the structure for an engine. Like, I mean, I just told you about, you know, an engine, you want to split the engine from the game, right? That's like, you know, the first way you can see that. A prototype, yeah. Yeah. Yeah, I mean, I would call that a prototype for what you wanted to do. Parser. A parser would be kind of like an engine feature, you could say. It's like something fitting of an engine. But it's like specific to the game. You're not like making a parser. You're not creating the parser, right? Because the parser is already, you know, the table and that kind of stuff. You're just parsing it for your game. So yeah, it's just mainly gameplay code. From what I see, dialogue. Everything is too specific to be called an engine. Or you could say, well, basically your engine and your game are like fused together. Well, that's it. I don't have a lot of things to say. I mean, there is not much, right? I mean, I could, you know, I don't really know much about the language, but so far it seems fine, right? I do understand, like, you have the camera speed. Well, I'm, like, actually, you want to set that in the objects. Wait, the object is cam speed. Okay, yeah, it's like row. Like, I would recommend you to just put that in a class, maybe. And... oh yeah, it is alright. Well, I won't say much about this because, you know, I'm not very familiar. But that's why I wanted to check out about the architecture in general. And I can't really see... well, I mean, the architecture is definitely lacking. But if it's a prototype, then, you know, it makes sense that you want to go fast. A game from scratch, but with Raylib. Yeah. I feel like, you know, it will be a bit unfair to make a prototype to test your thing, and, you know, trying to go fast for that, and, you know, give feedback, like criticize the code by saying it's not flexible enough and not abstract enough. Because if your goal is a prototype, then it's working well, right? You have your prototype and you have like only a few files. So I mean, I guess for a prototype it's good. For a prototype you don't want a lot of code, you don't want to abstract too much, I guess. So yeah, that's good enough. It's like 4 AM. I'm glad I finished my serialization. And thank you, Mr. Streamer, you're very kind, am I? I don't remember that. No, your code is so bad. Ew, who uses Odin nowadays? Yeah, actually that's a question. Why do you use Odin? Like, what's the reason for Odin? Or are you just familiar with that? What is your GLSL code? Where is your GLSL code? Feathers. Oh. Main. Fragment shader. Wait, what is this? It's GLSL? Is this GLSL? That's not GLSL. What is that? I mean, I guess it's GLSL, but what is point FS, fragment shader? So I guess maybe, oh, main, because the entry points and is the fragment shader, so it already knows it knows the entry point. Never mind, I get it. It's just a custom entry point. HLSL, no, it's GLSL. Actually, I don't know if there's no, it's probably GLSL. I don't remember. No, it's GLSL. I mean, GitHub was saying it was GLSL. RGB Northwest. Are you doing some blue? What are you doing? Lima? Yeah, it's just blurring experience. Oh, okay. Oh, so it was some blurring. Oh, FXIA. Wait, anti-aliasing? IA is supposed to be anti-aliasing, right? What is that? Fast approximate anti-aliasing. Right. Yeah, so that's why you have the blur. Got it. Makes sense. And you have some kind of... So you have, how is it called? A convolution? To change the color palette, you could say. Not the color palette, but like the color of what you're rendering. Well, how are you going? But how are you calling this? You have this in OBS, you have this in Resolve, you have this everywhere. It's called LUT, right? A lookup table. But I guess you use the name for rendering too. I mean, yeah, it's just a game. Did you know that that what? Let me think about this. I just took it from internet somewhere. FXIA code. Got it. Oh god. I just forgot. Check out my config point tunnel. Sure. Is it there or it's not? Looks clean. I like that. Why is there enough stats? I don't like that. Oh no, it's because it's part of the dialogue. Never mind. Wait, you have levels multiple times. Well, oh, you have multiple actors. Okay, I get it. I'm not a fan of tunnel for that kind of thing. For like hierarchy. For like hierarchy things, I would recommend JSON. Because there's like a bunch of support for JSON, and you have binary JSON if you want to optimize things. You must be forgot. What? Characters to levels, yeah. You must be forgot. Yes, I am the forgot. Tamil is human JSON. I mean, JSON is still human JSON, isn't it? No, I guess you're right. City Brave, hello. Oh, we have so many people right now. It's like 4 AM. I was giving an engine review. Well, a game review, a prototype review. Main. Oh, okay. Mr. Streamer reviews my game NGN. Yeah, your game NGN. Oh yeah, I wanted to test that. Let me check. I want to test. So basically what I did, City Brave, is I made serialization class for that uses C++20 for my chunks, to serialize my chunks. And I'm basically serializing them pretty well. So for example, let's say I have 100 block types. Okay? 100 block types. And I have 50 times 50 times 50 blocks in my chunk. Then when I run this, well, I made a test, a unit test to make sure it works well. And when I run this, actually I can't even see because it's succeeding every time. Oh no. It shouldn't be working. Wait. Godot C++ unit test. Print message. Whether it works or fails. What is it? Check message, require message, info. When it prints out if something fails. To log, require message. Well, this page just wants a message. Even on success. What? Let me go there. String hello. Case. What is that? Require, check. One. Century audio, no. Oh, message. Oh, message. That's it. That's message I want. So what I want is probably. Do I want to print everything? No, only if it fails. So I'm just gonna have. I'm just gonna have a string out maybe, and it's gonna be NB block types. And we are gonna have f string from this with NB voxels. No, this is not NB voxels. It's this. Point size. Okay. So that's one. Plus. Well, plus this. Then we have NB block types. Then we have amount of blocks. NB blocks. It's gonna be this. With, well, just NB blocks. NB voxels. Yeah, NB voxels. That. Oh. And then we have the size in bytes, I guess. Just bytes. Plus NB bytes. Well, NB bytes. And we have 2 bytes point size. So can I just go here? No, I can't. Do this. That's fine. And now I just want to print the out. Let me just start this. Like that. And we print. Okay, good. So it's going to give us some information about... Wait, yeah, no, that should be fine. It's going to give us some information about our test and about how well it's optimizing the memory for the serialization. So for 100 block types, what is it going to be? Here we go. Here we don't go, never mind. Yeah. Oh no. It's printing everything. Wait, what? Why is it doing this? Wait, what? I thought it wasn't supposed to print anything if... Huh? What is that? Oh, no. Oh! It's because info is getting triggered when... Wait. Let me check this. Print a message. Failed check. No. What about info? I don't actually have info here. Can I go in? Nope. What is info? Info macro. Oh. Info binds string or stream data to the current scope, printing it only if assertion fails. Right. So the problem is because of the scope. The problem is because of the scope. What I want is... I want this to be here. I want the scope to be something like this. So that way, it's only printing the info if this fails. But message is considered as something failing. And that's why it was printing. Should be good. So now it's not in the scope anymore, so it shouldn't just print random things. Like this. Well, no, it's not random really, but yeah. I guess what I want for compression, ideally, is a way to... Never mind. I want voxels to be... Well, if it's like contiguous, if I have like multiple blocks of grass next to each other, I don't want to describe all of them one by one. I want to say I have like 5 blocks of grass in this direction. Okay, here we go. So NV block types, 100. NV voxels, we have this. Wait, what? NV bytes. We have less bytes than we have voxels. Oh, this is so good. Because basically right now, at runtime, the memory it's taking is basically this times 4, which is this 500 bytes. So it's like 500 kilobytes, right? It's like the runtime. I might actually want to use this. Well, anyways. Okay. So then, what I actually have is this, which is only serialized. It's basically only, let's be generous, 110 kilobytes. So we basically divided the weight by 5. That's good. That's very good. That's very, very good. And it might be optimized even more in the end. I don't know about how... Like, I don't know about the speed, really. Like, what's the duration of this? I don't know, but that... It seems to be fast enough, right? Okay, good. Serialized. Yeah, well, basically my idea was that each chunk would have its own table, would have its own voxel map. That way we can reduce the amount of block types available. Like, for example, if a chunk only has grass and stone, then it's only 2 possibilities. So it's only going to be one bit, and we can compress it even more. Right, that just means we have to store the table though. But yeah, that's it. That's the idea. If we only have air, for example, that means it's going to be air everywhere. It's really, but wait, is it going to be 0? But yeah, technically it should be 1 bit. Yeah, it should be 1 bit. Should be 1 bit maximum. And that means it's only going to be, well, 1 bit times every voxel. So then you have your amount of voxels, you divide by 8, and that gives you the memory waste. Right. I mean, I'm pretty happy with that. I did 2 block name. I'm really gonna have to use this voxel map though, because I'm not using it. I guess what I actually want is, in the end, I want a conversion table. So let's go back there. Yeah, I know, I was supposed to stop. But let me check this first. So I have all of this. And I have the blocks. What I want is to serialize with cube chunk. I'm not sure. Like maybe something like this, right? Bytes. So, well, yeah, so it should be something like serialize. Cube chunk. What was it? It's not memory, it's not anchor, it's not storage. Storage map out byte. So the voxel map. We need this. And we need the storage bytes. Which is gonna be this. 2 voxel bytes. There. Yeah, I mean, if the size is in kilobytes, then I guess that's not that bad. Minecraft chunk size, memory size. I mean, it depends, right? It's dynamic, but 100 to 200 kilobytes. of uncompressed active RAM in memory. Oh, so wait. Am I just... Is it just bad? Is what I have just bad? I mean, I have more blocks. No, Minecraft has 8 though. Wait, so what was the... Wait. 110 kilobytes. That sucks. Minecraft is better. Well, not really. Almost. And 10 to 50 kilobytes when compressed? How do you do that? So it's 16... Oh, right. No, it's smaller though. No, it's smaller. 16 times 384 times 16. Okay, it gives us this, right? But in my case, I have 15 times 15 times 15. It's this. It's like basically 1 to 5. I guess it's a bit bigger, but not that much actually. It's around the same. So 10 kilobytes. Oh, I guess there's the air, right? The air is not... Yeah, I mean... Yeah, I mean, the air is cheating, so I guess you divide by 2. But still, 10 kilobytes. Well, 15 kilobytes is more... Makes more sense. What? What? Yeah, it's a bit old. It's a bit old. Anyways, we can optimize this however we want, really. Yeah, I mean, it should be pretty simple to optimize things with by preventing repetitions. But anyways, so what I want is the bytes, voxel bytes. I'm setting this. And yeah, I need the voxel map though. So voxel map is going to be... I mean, I guess I can get the current voxel database, technically, can I? ID to block name. ID to block name. Wait. I mean, I guess I want this in both directions. Would be ideal. Would it? Ah! Voxel name to ID. ID to voxel name. Oh. Count 0, C++ 20, that's fine. And yeah, so I mean, technically we should return str, right? It's void, so it's not gonna do anything, but well, I don't like string. Well, I guess it's fine. I guess this shouldn't be bytes, but okay. Oh, it's bytes. Right, I forgot about this. Let's maybe just have string. It's not, well, it's out. Out string. Like this, here we go. So now what I want. What I wanted, what is it that I wanted? I have no idea. Yeah, I know I want the conversion. So I have the voxel map. Let me think. So I mean, technically it should be good. We have the map. I mean, it should be the chunk map. Maybe. 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 Chunk map. Looks good enough. Yeah, I just need the size, really. That's kind of a shame, but okay. And then what I want is... I also have another map. So this one is going to be... chunk voxel map. And we potentially save it, right? Oh. Shouldn't be about this one. But okay, we have this. And we want a function to convert from one to another. Convert. Like map. Well, no, okay, convert. Convert from this to storage. Well, two. Well, we're gonna have two maps, right? We have the from and we have the to. We have from. We have to. And now this function is gonna be here. And we're just gonna create a map first. From one to the other. So we can have for every integer. Yeah, that's it. I'm gonna loop. We have from. Or what? ID to... it doesn't really matter. For auto x in this. So it's a pair, I suppose. It should be a pair. What is it? Key value. Int32 string. uint32 string name. It's like basically the pair, right? Should it be like const? Or something? Const a hash map to all of this. This? Yeah, nah. I don't know. Map key value to key value. Oh, it's map key value. Wait. Key value int uint. Oh. Oh, is it a uint? Is that a problem? Oh, it is. It's not the same type. Here we go. So we have the pair. Good, it's working now. And for every... Well... For every name, so pair points value, then I'm going to search into 2. Into 2 to voxel into ID. Try guess. Does that exist? Get PTR. It's gonna return an integer, which is good. So we put that inside. And we have value. Value? Oh. Yeah, my head is just blah. So it's a pointer towards the value. And basically we should be able to have... Well, I should have an array. Like local vector. This. Conversion array. I'm gonna resize. And initialized. Boop. We have this. We resize. From resize. And then what I want is at each index. So the index is gonna be pair points key. And this is just gonna be equal to value basically. If this is valid. Okay, it should be good. And I'm gonna stop here because I'm falling asleep. It's 4 AM and a half. So thanks a lot for watching. Thanks a lot for joining. I'm really happy with what I have. Wait, what's that? Const int of uint. Huh? Can I have that? I don't get it. That's fine. That's fine, that's fine. So, do you have anyone? Let me actually just go there. Oh, I have funny boys. We have the Chomp, the Chomp guy. We have Adam. It's been a while I haven't raided Adam. We have me. Hello, me. Yeah, I guess we might just run... Well, we might just raid Adam. Let's do that. Ooh. Here we go. And other than that, I really want to fix this, but can be used to initialize an entity of type uint32. So can I just do that? Is it just going to work? Oh, but it's supposed to be const, right? Now it works. Well, I mean, I guess it works. Value, what is value? From. Well, that's a problem. Now that makes a bit more sense. Besides uninitialize, I should be able to get everything. Actually, if it's not, it's just going to be 0. As we have this equals 0. Do we? I mean, I guess, yeah. And at the end, so we have the array. So it's actually a conversion array, because then it's like pretty trivial once you have the array. It's just going to be for every block. Oh wait. Oh, it's been... Oh, I just read it. Okay, be right back.